Hello students, my name is Debajyoti Adhikary. Today I am going to teach you searching algorithm. In your syllabus, we have two searching algorithm. One is linear searching algorithm, another one is binary searching algorithm. So what is linear searching algorithm? Linear search is also called as sequential search algorithm. It is the simplest searching algorithm. In linear search, we simply traverse the list completely and match each element of the list with the item whose location is to be found. If the match is found, then the location of the item is returned. Otherwise, the algorithm returns null. So, using this definition, you can easily understand the linear searching algorithm just search the arrays from the beginning up to the end. If the target element is found from this array, it just return the index. Otherwise, it's written the null value. The steps to execute the linear search. First, we have to traverse the array elements using a for loop. So here we are using a for loop to traverse the whole array. Then in each iteration of for loop, compare the search element with the current array element. Each iteration, we are just comparing the search element or the target element with the index value or index containing element. If the element match, then return the index of the corresponding array element. If the element does not match, then move to the next element. Okay, it is simply if the element find, then it return the index, or if not find, then it move to the next index. If there is no match or the search element is not present in the given array, it just return -1. If the search element is not present, it just return -1. Okay, this is the steps to execute the linear search. Here is the algorithm of this process. Linear search, A, N, and val. What is the A? A is the given array. N, what is N? N is the length of this array. And val is the value of search element. Okay, or you can say the val is the target element. Then step one, set pos equal -1. What is pos? Pos is a variable. We are initializing this variable with -1. Step two, set I equal 1. What is I? I is also one variable. We are initializing with the value of 1. Step 3, repeat step 4 while I less or equal n. So here you are just traversing the whole array. Step 4, if ai equal val. So in this step, we are just comparing the array item with our target item. Pos equal I, if match, if target item match with the array element, we just return the index value on the pos variable. Okay, and we print this pos or POS and go to the step 6. Step 6 means we just simply execute from this algorithm. And end of if first iteration is not, it does not match with this target value. So what we have done, what we have to do, set I equal to I plus 1, which means we are just going forward the next iteration. Okay, and in this way we are checking from index number 0 to end of this array. Okay, if any element is not matched, then pos equal -1. I've already told you, if array is not found from this array, we have said just set the value of pos equal to -1 and print value is not present in this array. Then execute from this program. This is a very simple algorithm. Then let's understand the working principle of this algorithm. So here you can see one array is given, the index number 0 to 8, and the value is 70, 40, 30, 11, 57, 41, 25, 15, and 42. And here the target element is 41, and we are storing this inside a variable k. Here you can see. So I have already told that in this algorithm we check the whole array from the beginning to end of this array. So first check the index number 0. If index number 0 that's containing 72 is equal to k means 41. No, it's not equal to 41. Just move towards the next index. Next, check the index number 1. Is it equal to 41? 40 equal to 41? Yes or no? No. Next, move to the index number 2. 30 equal to 41? No. Move to the index number 3. 11 equal to 41? No. Next, index number 4. Uh, 57 equal to 41? No. Next, move to the index number 5. Here you can see index number 5 is just matching with our targeted value. So what you have done? Here, this algorithm just return the index number of this array. Here the output will be 5 because this index number is containing our targeted value. This is the code of this algorithm. Here has included stdio.h. This is the header file. And in linear search, here you can see the linear search. What is linear search? Linear search is our user defined function. This is nothing but a user defined function. Okay. And here, okay, I'm using a pen. You can see A means our given array, N means the length of this array, and val is the target value or the search value. For we are using a for loop, initializing with I we are initializing with 0. So this is not mandatory. You can initialize by 1 also. Then if AI equal val, and what we are doing is this code, we are trying to find out, or we are trying to match our target value from the index value. Okay. If match, then return I plus 1. Why I plus 1? Because I've already told we are starting the index number 0. So to get the correct position of this uh, element, we are just adding 1. Okay. Or if no match, it just return -1. Int main, this is main function, and this is the given array, already I have told you, this is given array 70, 40, 30, 11, 47, and 57, 41, 25, 15, and 52. This is given array, our targeted value 41. Okay. And this is for to get the size of this array, and we are just calling our function, and this is for print the whole array. Now if the array is equal -1, if not found, then element is not present in this array, it's just written. And if present, if the index number is present, or if is not equal to -1, then it print its position. Okay, it's very simple. Now we can see here the output of this code also. Okay. Yes, just look at this. Here the output. This is the array. Our target value is 41 and the position is 6. Count 1, 2, 3, 4, 5, and 6. Okay. Complexity of this algorithm. Time complexity of this algorithm. The best case of this algorithm is big O 1. The time complexity of best case of this algorithm is big O 1 because when the our target element is present on the index number 0, so only one swap is required. So or one pass is required. On that scenario, the index time complexity is big of 1. Or on the other hand, the worst case or average case, um, the time complexity is big of n because it takes uh, in number of time because it's just required to search from n number of elements. Advantage of this linear search. What is the advantage? Linear search can be used irrespective of whether the array is sorted or not. So it's not mandatory to sort the array previously. If it does not require any additional memory, it is well suited algorithm for small data set. Okay. Drawbacks. What is the drawbacks from this algorithm? Linear search has a time complexity of big of n, in which makes it slow for large data set. It's not suitable for large data set. Why? Because its time complexity for worst case and average case is big of n. On this scenario, for large data set, it takes very long time and it gets slow. So it's not suitable for large data set. So we have um, already have teach learn linear search. Now it's time to learn binary search. So what is binary search? Binary search follows the divide and conquer. So first, what we know it works on divide and conquer mechanism. Okay, in which the list is divided into two hubs and the item is compared with the middle element of the list. If the match is found, then the location of this middle element is returned. Otherwise, we search into either of the hubs depending upon the result produced through the match. So, what this algorithm does, it just divide. First is just generate the mid of this array or given array and try to match our target element. If it match with the target element, just return the position. If not, if not, and also I have told you that here prerequisite is array should be sorted. Array should be sorted. It may be ascending or descending. So if the target element is smaller than mid, then we just search for or the left hubs or left subarray, or if that our target element is greater than mid, then we search on the right subarray or the right hubs. Condition to apply, I already told you. Binary search can be implemented on sorted array. Okay. If array is not sorted, so first of all, sort the array and then apply the binary search. Algorithm here, given algorithm, binary search, a lower bound, upper bound, and val. Some parameters. What is a? A is given array. Lower bound means lower index of this array, and upper bound means the higher index of the array, and val means the target value or the search value. Okay. Step one, set big lower bound. Big means the beginning. Big equal to lower bound. We are just setting the big of the lower value of this array, and end we are setting the value of the upper bound inside the end, and was equal to -1, as well as the totally same with the linear search. We are initializing the was with the -1. Step 2, repeat step 3 and step 4 while big less or equal end. So here in this line, it's try to show it algorithm will run until one element is present in the array. Then find the mid. Here find the mid. Mid equal to big plus end divided by 2. Okay, beginning plus end divided by 2. We can find the mid. Then if a mid equal to val, if I have already told you, in this algorithm we are just comparing mid value with our target value. No other value we are comparing, only the mid and target. We are comparing only these two values. Okay. If target value match with our mid, then just uh, set the index number on the false, and step 6 and execute if not match. The very interesting part. Else if a mid greater than value, here just see, here a mid greater than value. So if the mid value is greater than value, our target value, so what we done? A equal to mid -1. It means our targeted value is present inside the left hubs. Okay, or a left subarray. Else, if less than, then beginning equal to mid +1. It means our target value present the right hub. Then again iterate this, again go through this algorithm and divide by the mid. Again calculate the mid and search, compare with all this line. A mid and val, again compare with the value and mid, and again recursively compare, divide and conquer this whole array. Okay. If pos equal -1, then if our target value is not matched in this array, then value is not present in this array, and if present, it just return the index number from this array. Now this is the working principle. Here a given array, you can see the index number 0 to 8. The value is 10, 12, 24, 29, 39, 40, 51, 56, and 69. With the element to search is k equal to 56. Here we have to calculate the mid. The formula I have already told. Big plus n by 2. So in this given array, big is 0, end is 8, and the mid is 4. Here, you can see our target value is 6. So here mid is 4. So is 39 is equal to 56? Yes or no? No. Then compare. That is pencil. Yes. Then mid less than k. Mid less than k. It means 39 less than 56. It means our target value on the right sub-array, because we know this array is already sorted, so we can guess our target value in the right hand side of this array. So for this purpose, set the big mid plus 1 and end value will be as it is. Okay. Now the mid is beginning plus end by 2. It means 5 plus 8 means 13 by 2 means 6. We are just getting the integer value. Okay. So now the mid is 6. This is mid. Just look at this. Okay. Now mid is 6. And just compare. Is 51 equal to 56? Yes or no? No. Here mid less than k. Here also mid less than k. So beginning equal to mid plus 1. Now beginning is 7 and end is 8. Here you can see the mid is less than k. It means 51 less than 56. So now big is mid plus 1 equal to 7 and end is 8. So now mid is big plus end means 7 plus 8 means 15 by 2, which means now the mid is 7. We're just trying to get the flow value. Okay. So now the mid is 7. Okay. No. Mid is 7. And now compare with our target value. Our target value was 56. And here mid is 56. Okay. Okay. Just matched. Okay. It just return the location of this mid. Okay. Location is 7 in this algorithm. Just return the location of this mid. Right now 7. So this is very simple algorithm. How is compared? It just divide our array using the mid and find that our target value. How? With the compare with the mid only. Okay. Time complexity. Here the base time complexity on base case big O 1. Obviously, if the search element is present on the right first index, the time complexity is big of 1. On the other side, average case and worst case, the time complexity is log big of log n. Okay. So it takes less time compared to linear search. This is the code of this algorithm here. See, binary search, int a, big, n, and val. A means this is given array, big means beginning, and end means end of this array, and val means the target value. And mid, okay, mid is another one variable we take. If end greater or equal to big, it's mean it has at least one element. Okay, calculate the mid, big plus n by 2. Okay, if a mid equal val, if so in this line we are trying to match with the mid with our target value. If value match with our target value, we return mid plus 1. If not match, if a mid less than val, then what we have to done? Beginning equal to mid plus 1 and end will be the as it is same. Okay, and if mid is greater than value, then beginning is same, end will be the mid minus. Okay, here is the given array. I have already told this whole code that it is not equal to minus 1, then it's return the index value of this uh, mid. Okay, advantages of binary search. Binary search is faster than linear search, especially for large data series. So I have already told you linear search is suitable for small data sets and binary search is suitable for large data set. Okay, binary search is well suited for searching large data sets that are stored in external memory, such as on a hard drive or in the or disadvantage of binary search, the array should be sorted. Okay, okay, goodbye.